Okay, so we are going to move on to our last lesson of this unit, and it's called Taken Out of Context, and it's 5.10. So we're going to be practicing here. So far, you've learned how to solve a system of equations by graphing, by substitution, and by elimination. And we're putting those all together to look at a couple of things like which systems are easier to solve which way. And then also there's a couple more new ideas that will come out in this lesson. Okay. So you're going to do the jumpstart by yourself. So go ahead and pause here and like reorder those, put those things in order. Okay. And all you're supposed to do is just start here and then put those items in order. Okay. So today you'll be able to solve systems of equations, identify systems that have no solutions or an infinite number of solutions, right? So no solutions, like you've seen equations with that. So there's a kind of like a similar idea in systems, but infinite number of solutions, I think you've seen also. And so there's also a similar idea in terms of systems. If you haven't seen them, no big deal. I'll explain what it means and how it looks like on a graph. So the questions you'll be able to answer is, do all systems of linear equations have a solution? And based on the focus, you should be able to answer that already. Can a system of linear equations have more than one solution? What does that mean? And what features of a context help me think about the nature of the solution? Okay. So we're just going to continue on with Carlos and Clarita and their shopping. It says, write a shopping scenario similar to those in Shopping for Cats and Dogs to fit each of the following systems of equations. Then use elimination of variable methods you invented in the previous lesson to solve the system. Some of the systems may have interesting solutions or unusual solutions. See if you can explain them in terms of the shopping scenarios that you wrote. If you can't find the solutions to the system by elimination, try solving the system graphically or by substitution. Okay. Okay. So the very first thing they tell you to do is write a scenario for this. And so it could be, you bought 3 bags of cat food and 4 bags of dog food, and you paid $23. And then you bought the next week you bought 5 bags of cat food and 3 bags of dog food. And this time you only paid $31. Okay. So whatever scenario that you come up with, that is fine. Practicing writing scenarios are really, really important because it gives you an idea of what we're actually doing and not just doing random math problems, right? Okay. So, now that you've done that, we're going to solve this equation. So if you remember, your options are substitution, elimination, or substitution or elimination. Okay. So for this particular one, I would not choose substitution because if you think about solving for like say X, like because X has a 3 in front of it, it means I'm going to have to divide by 3. And I don't want to have to think about 23 divided by 3. So same thing goes with this one and this one and this one. So I'm actually going to use elimination. And elimination, if you remember elimination from the previous 2 lessons, you want one of these variables, either X or Y, to be eliminated. In order to do that, they needed to match. These don't match and neither do these. So we need to figure out a way to do that. So you're going to pick which you want to eliminate, either X or Y. And in this case, I'd probably eliminate Y because if I think about what number does 4X or 4Y and 3Y go into, what number does 4 and 3 go into? That's a lot smaller than this number over here. And not a lot smaller, just smaller. So what number does 4 and 3 go into? And some of you would be like, oh, 12. So that means over here, I'm going to have 12Y and 12Y. And so now if I subtract those, I would eliminate those and then I would be happy, right? Okay. So then I need to think, okay, well, what am I going to multiply 4y by to get 12y? What am I multiplying 4 by to get 12? And so you'll say, oh, I'm going to multiply by 3. And you're right, because 4y times 3 is 12. So that means I'm going to multiply every single piece by 3, right? So 3 times 3x, that's 9x. 3 times 4y, that's 12y. 3 times 23 is 69. Okay. So go ahead and do the same thing that we did right here, except this time you're thinking about this number. What am I going to multiply 3 by to get to 12y? What am I multiplying 3y by to get 12y? And hopefully you said by 4. And then now go ahead and fill that in by multiplying every single piece by 4. I'll wait for you. Give you a couple of seconds. And you're like, oh, I multiplied by that. And so here it is. I get 20x plus 12y equals to 124, right? And then so now I'm going to see, like, look at the difference between these two equations. So the difference between, I'm going to subtract, let's see, I would like to do not negatives. So I'm going to kind of switch these two. I'm going to put this one up here. So 20x plus 12y equals to 124. And I'm going to put this one down here and put 9x plus 12y equals to 69. And then I'm going to subtract these two. So then what am I left with? I'm left with 11x. And then these canceled, so that's why I'm happy. And then so I'm left with 60. Okay, let's see. That's 70. So 50 for 55. So that means x is 5. Right. So the moment that I'm here, I kicked you back into 6th grade. And if 11x equals to 55, then divide both sides by 11, x is equal to 5. So here's one of my answers. Yay, me. Right. And then how do I find the other variable? Well, I'm just going to go plug back into one of my original equations and then do it that way. I like that first equation, so I'm going to use that one. So let's see. I get 3x plus 4y equals to 23. So then this is that 5 from earlier. So I'm going to do that. And so that's 15 plus 4y equals to 23. So now I kicked you back to 8th grade, and this is an equation that you should be comfortable with, if not just practice, right? So I'm going to subtract 15 on both sides, so I get 4y equals to 8. So then that implies that y equals to 2, and there's my other answer, and then I'm going to check my answer by plugging in here. So when I plug in here, sometimes I just use my head, and I'm just subtracting and adding in my head. But because I need to show you what I'm talking about, I'm going to do this here. So I'm going to go 3 times x, which is 5. So 3 times 5 plus 4 times y, which is 2. So times 2, and it's 23. Notice this 23 matches that 23. And now I'm going to plug into the second equation. So I got 5 times x, which is 5, plus 3 times 2, which is 31. And notice this 31 matches this 31, so I know my answer is perfect. Okay. So this is going to be the name of the game. All I'm going to be doing is doing that over and over again. Just as a reminder, I can plug both of these into Desmos to check my answer. But of course, Ms. Johnson is going to ask you to show all your work on a quiz or a test. So just kind of keep that in mind. Oh, let me turn up these other guys that I used earlier. Okay, there we go. And then my second equation is 5x plus 3y equals to 31. 31. There it goes. And so if you see, there's this solution right there, and it says my solution is 5, 2. 5 comma 2. So I usually like to finish off my answer by writing it as a point because it reminds me that graphically this is a point and I'm done. Okay. If you're like using like C's and D's like we were for the last lesson, it's okay to write it alphabetical, or you can write like what it is. Like you could put a C above here and a D above here so everybody knows what you're talking about. But this is generally how I'm going to do every single problem. I'm going to either figure out, can I use elimination on this? Can I use substitution on this? And then I'm just going to move forward. Okay. All right, so second problem. So again, they wanted you to come up with a scenario of this, and I don't know, maybe it's like 2 cat toys plus 3 dog toys equals to $14, and 4 cat toys plus 6 dog toys equals to $28, right? And then, so now they want us to use this. So notice here again, probably not going to use substitution, because dividing 3 by 2, I don't like it. Dividing by 3 and getting 2, no, I don't like any of these numbers. Nothing's like popping out to me to actually solve. You'll see in a couple of rows, I'm probably going to use substitution on a couple of these just so that you can be reminded before our test. Okay, so here, I want to use elimination. The way I'm going to use elimination is this. Again, I want something to match so I can actually eliminate. Here, the x's don't match. Here, the y's don't match. So I'm a little bit like I have to actually multiply. So what could I multiply this by so that maybe I'll have 4x, like the x's cancel. And you're like, oh, I could double this, because then the 2x would match the 4x. And I'm like, yes, let's do that. Okay, so then I'm going to go here and I'm just going to move it down a little so it doesn't, run into that other math. So I'm going to say times by 2. So 4x plus 6y equals to 28. And then I'm just going to copy my second equation. And you should already be noticing something. So some of you may have noticed it in the very beginning. You're like, hey, Ms. Johnson, look, I can multiply by 2 to get that, multiply 2 to get that, and multiply 2 to get that. Exactly. And then that's why you have these two equations being exactly the same. So if I tried to eliminate this, right? So again, I'm going to subtract. Look what happens. When I subtract, 4x minus 4x is 0. 6y minus 6y, well, that's 0. So that's 0 plus 0. 28 minus 28, well, that's 0. And so this is a funny equation because we eliminated x's and y's at the same time. And then we get the statement at the end, 0 equals 0. 0 equals 0 is a true statement, okay? And because it's a true statement and we've eliminated all the variables, it means that, well, actually, let me show you my what the graph actually looks like. So I'm going to, let me just close some of these out because there are like a lot of them. So I'm going to graph both of these equations and see what happens. Okay. There you go. Sorry, I just wanted to eliminate all that. So I'm going to graph 2x plus 3y equals to 14. I'm going to graph 4x. Now pay attention, because if you blink, you might lose it. 4x plus 6y equals to 28. Did you all see what happened right there? If I unclick the red one to show the black one and the red one are sitting right on top of each other. So this is actually called infinitely many solutions. So the way you'd write your solution is you'd say infinitely many solutions. You can write out the word infinitely too. But my point is the answer is every single point on that line is a solution. So it's because these lines represent, it's because these equations over here represent the same line. So these two represent the same line. What does that mean, Ms. Johnson? So You guys call me Miss Johnson, Mrs. Johnson, right? And then my children call me mom. So it's two names representing the same line. Okay? That's all that means. So it's infinitely many solutions, Miss Johnson. Yeah. So if I plugged in this point right here, what point is that? Let's see. 7 comma 0 to both of the equations, it would come out as true. If I did another one, let's see, this point right here, 5.28 comma 1.147, that would also work. And every single point on this line, even the points that you can't see that are way off screen, that way or the other way, you're going to get a solution to that system. Okay? So all the points on the line are solutions. Okay, so I'm going to write that out. All the points on the line, 2x plus 3y equals to 14 are solutions. Okay. That was written really messy, so hopefully you understood that. Okay, let's move on. It says, here's our next one. So, sorry, I wanted to talk about one more thing. So, when the reason why, if we go back to the context of it, I think we were using toys. If I doubled my purchase, like if I went and bought 2 cat toys and 3 dog toys and I paid $14 and I doubled my purchase the next week, I don't know how much each of the toys is because all I did is I doubled my purchase, right? I need more information in order for me to figure that out. Okay. Okay. So let's look at this next one. So this next one, again, I'm trying to think about can I use substitution, and I don't see anything that's pretty clean. If you look at number 4, I will be able to use substitution right here for the second equation for y. It looks pretty clean, so I'll actually do that so that you can remember. But this one I can't. So then I'm thinking, okay, I can eliminate x's or y's, and you're like, oh, Ms. Johnson, I can eliminate x's by tripling this first equation. And I'm like, you're right. So let's do that. So we're going to multiply the first equation by 3. So I get 9x plus 6y equals to 60. And my second equation, I'm just going to copy down. I get 9x plus 6y equals to 36. And some of you are already seeing some like interesting patterns, right? And you're like, Ms. Johnson, the 9x's cancel, you're happy. But at the same time, the 6y's cancel. And so are you happier? No. So on the left side, it equals to 0. And then on the right side, if I subtract them, I get 24. And so I get this statement. Earlier up here, I got a true statement. 0 plus 0 is 0. Down here, I get 0 plus 0 equals to 24. And the last time I checked, if I had nothing, I had no money in my pocket and no money in my wallet, I don't have $24. That's not the way it works, right? So this is a false statement. And what do you think the graph is going to look like here? Or what do you think the solution is going to be here? Okay, so that's what I want you to think about as I go over here and I type in my equations. So I get 3x plus 2y equals to 20. And my other equation is 9x plus 6y equals to 36. Ms. Johnson, look at those lines. What would we call those lines? So if you remember from a long time ago, you would call them parallel. But that doesn't help you, right? Because I'm looking for their intersection. So they don't have an intersection. So what does that mean? So this implies that the answer is no solution. And what does no solution mean? It means there are no points that these two equations have in common. Okay. And if we go back to our equations, what happened here? Well, we tripled our purchase, right? We tripled our purchase, right? We tripled this. We tripled the number of, I don't know, dog leashes and the number of cat brushes. But what didn't happen is the price didn't triple. I actually paid more for my purchase this time, which is not right. Okay. So graphically, it's parallel lines. So again, when I get a true statement, it means every point on the line is a solution. When I get a false statement like this, and I need to cross this out because that's not true, 0 doesn't equal to 24. I get parallel lines, which means no solution. Okay. So for this last one, I'm going to remind you how to use substitution just because we've been in the land of elimination and I want to show you how to do substitution. So I'd probably solve the first equation by y. So I'm going to solve this first equation by y. So I get 4x plus 2y equals to 8. And I'm going to solve for y. I'm going to solve for this guy. So I'm going to subtract 4x from both sides. So I get 2y equals to negative 4x plus 8, right? And then because I want y by itself, I'm going to divide every single piece by 2. So I get y is equal to negative 2x plus 4. So I'm going to actually take this and substitute it into here to find out what x is, okay? So I'm going to take my equation, my second equation. I get 5x plus 3 times something equals to 9. And I'm going to take all of this something and put it in here, right? So I get negative 2x plus 4. So what happens? Let's see. I get 5x, and then now I have to distribute this thing. So I'm going to distribute like this. So I get negative 6x plus 12 equals to 9. Right? And then now if you look, I've kicked you back to 8th grade because their y kind of got substituted out. So now I'm just going to solve this thing. Let's see. These two combine to be negative x. So plus 12 equals to 9. So the next thing I could subtract 12 from both sides. I get negative x equals to negative 3. That means x equals to 3. So in the point situation, I got a 3 as my x, right? So then what do? I need to find my y. So I'm just going to plug this guy right into here. So I get y equals to negative 2 big parentheses plus 4. And I'm going to pull this 3 into here. So I get negative 6. Let's see. I get negative 6 plus 4, and that's just negative 2. So y is negative 2. And of course, I would substitute, I would check my answer to make sure that that completely makes sense. Okay, number 5. It says 3 of Carlos included his friends are purchasing school supplies at the bookstore. Stan buys a notebook, 3 packages of pencils, and 2 markers for $7.50. Jan buys 2 notebooks, 6 packages of pencils, 5 markers for $15.50, and Fran buys 1 notebook, 2 packages of pencils, and 2 markers for $6.25. How much did each of these 3 items cost? The story could be represented like this. Explain in words or symbols how you can use your intuitive reasoning about the purchase price for each item. So this can be pretty intimidating if you look at it, right? But which equations, what do you notice? That's what I first want to ask. What do you notice? So what I notice is that first equation has an N, has an N and an N. It also has a 2M and a 2M. but it does have a little bit of difference for that 3p and 2p. So the difference there in between their two purchases, whoever that was, let's see, was that Stan? Between Stan and Jan. No, just kidding. Between Stan and Fran. Ha, that's funny. Between Stan and Fran, right, is the one package of pencils. That's all that's different. So that tells me one package of pencils is equal to however much this difference is between here and here, right? So that's $1.25. So one package of pencil cost $1.25. So notice I didn't even, like, if you think about elimination, I've had whole pages of work to solve a system of equations, but just by taking a second and looking, you could see the answer kind of like come out to you. Okay, so what else do you see then? Okay, does anybody see anything else that's kind of like, oh, that looks pretty cool too? Yeah, and so the next one that I kind of see that's pretty neat is I see the first equation and the second equation is almost like double, right? N times 2 is 2n, n times 2 is 2n, 3p times 2 is 6p, and then 2m times 2 is 4m. So that's my difference there. That's going to be my 1m. So between these two, so double the first one. So let me just write that out. So 2n plus 6m plus 4m. Am I writing this right? No, that's supposed to be a p. Equals to $15. And then the second one, I'm just going to write the same. Right. And if you notice, like in terms of elimination, these eliminated. And so my 1m is going to be what, 50 cents? So there's m and there's n. No, sorry, there's m and p. So now all I'm looking for is n. And so I'm going to use that last equation to plug all this into. So n plus 2p plus 2m equals to 625. So p is $1.25. And then m is 50 cents. Oops. So what is that? So n plus 250 plus $1 equals to 625. Right, and so that's 350. So n plus 350 equals to 625. So if I subtracted, n would be what? $3. So $2.75. And there goes your answer. So when you're doing equations like this, it's a really good idea to just take a second and just look at what you see. And so does everybody see what I see? I see, oh, Miss Johnson, I see that this one right here, these ends match. And actually the two m's match. Right? And so you were able to figure out what P was. And then this one, I noticed that this was like almost double, which is really helpful. Okay, so last but not least, we're going to just do our takeaways to make sure that you remember what it is that we learned and see if there's any new words that I want to show you. Oops, I went too far. Okay, so it says describe the following systems of equation. A dependent system is this was when we had, so the picture looks like this. So I'm going to try to draw two lines right on top of each other so you guys can see, right? So the way it looked was, what was that? What was that equation? Let me just go back and look. What was the one with infinitely many? Yeah, it was 2x plus 3y equals to 14. So this one looks like, what number was that? Sorry. That was number 2. Okay, and so one equation was a multiple of the other, right? The answer was infinitely many solutions. right? Versus down here, inconsistent. The word inconsistent is another way of saying no solution. Inconsistent, like the actual picture of it looks like this, right? It looked like one line was here and the other line was right here, and there was no solution. So it looked like parallel lines. This means parallel, right? And then last but not least, it says find a unique solution for the variables in an independent system of equations requires that you have the same number of equations for the unique number of variables. So notice here, when we were solving this last system, because we had 3 variables, you had 3 equations. For this one here, because we had 2 variables, right, x and y, we had 2 equations. So take your time with this. See if there's anything here that didn't make sense, and like go back to that part and review so that it'll make a lot of sense. Okay. Don't forget to check your answers using the different methods that we checked. I hope you have a wonderful day and see you in our next video.